Okay, these are the solutions from your second exam. So for question number 1, you had to find k, and it's a continuity problem, so you're going to go through the 3 steps, and the first thing you're going to want to do is to find f of 4. And when f is exactly 4, you're going to use the function k. So f of 4 is k. And then you're going to need the limit of f of x as x approaches 4. So that means you're not exactly 4, that means that you're using the first function. And I cannot substitute 4 into here, I'll get 0 in the denominator, so I will factor the numerator. And then I can cancel, and I'm just left with x plus 4, so I can definitely substitute into that. And I get 8 as the answer, and that was choice D. Right there. Okay, now moving on to question number 2, and this was a limit problem as x approaches a. Okay, so I cannot substitute a in there for x because then I'll get a squared minus a squared, which will give me 0. However, I can factor, and my numerator factors to this, and my denominator factors to this. So you can see the x minus a's cancel, and now I can substitute a in there, so I'll get a minus a over a plus a, and that gives me 0 over 2a, which equals 0, and that was choice D. Okay, question number 3 was just asking you a general question about what must be true about continuity. So the first one says that f of c exists, and that is definitely true. That has to happen if it's continuous. And then the limit of f of x as x approaches c exists, and that definitely needs to be done. That was the step 2. And then the third step is that f of c equals the limit of f of x as x approaches c. We all know that's true. So it was all 3 of them, 1, 2, and 3. So that was choice E. And finally, the last problem on this page, number 4, is another continuity problem. So you're just going to do each step like we normally do. So step 1 is going to be f of 0. And you're told that when x is 0, f of 0 is 1. And then we're going to do the limit as x approaches 0. And so that means it's not exactly 0, so we're going to use the top function. You cannot substitute 0 in there, you'll get 0 in the denominator, but you can factor the numerator. And when you do that, you can see the x squareds cancel, and now you can substitute 0 in there, and you get 0 plus 1 equals 1. So f of 0 is equal to the limit as x approaches 0, so therefore the function is continuous. So choice 1, does f of 0 exist? Yes, that's true. Does the limit as x approaches 0 exist? Yes, that's true. Does that mean that they're continuous? Yes. All 3 were correct. So therefore, for choice 4, the answer was E. Okay, now we're going to move on to number 5. And 5 is asking all about different discontinuities. So we're going to look at one thing at a time. So if you look at the denominator, you have x squared minus 9. If you set that equal to 0, and then factor, then we know that there are definitely discontinuities at x equals negative 3 and x equals 3. So we don't know which kind they are though yet. So However, we do know that they have to either be essential or removable, because you get essential and removable discontinuities by setting the denominator equal to 0. So that means that B could not possibly be the answer, because it's not a jump discontinuity. It can't be D, because D says non-removable discontinuities. Forget that. And if you actually graph this function, it's going to look like this. And you did have the use of your calculator for the test. Here's an asymptote here, and it looks like something like this. So if you graph it, this is what it's going to look like. You'll see there's an asymptote at x equals 3. So that means when x equals 3, there has to be an essential discontinuity. So if you look at all these choices, though, that's not a choice. However, whatever happened to when x equals negative 3? Well, at x equals negative 3, you can see on the graph that there's no asymptote there. That means it has to be a removable discontinuity. So that means that A was the answer. So you could have tried to factor the numerator. It might have taken the entire time of the test. So it's a little bit easier to just, by a process of elimination, see what would make the most sense here. Okay, now we're going to go on to number 6, and this is just a simple limit problem. And can I substitute? Yes, I can. So I'm going to get 2 squared minus 4 over 2 squared plus 4. That gives me 4 minus 4 over 4 plus 4, which gives me 0 over 8, which is just equal to 0, and that was choice B. That one was pretty simple. And number 7 was just a limit as x goes to infinity, and you can see the largest degree in the numerator is a 2, largest degree in the denominator is a 2, so we're going to use the coefficients. Coefficient in the numerator is negative 1, coefficient in the denominator is 1, so negative 1 over 1 equals 1, and that was, I'm sorry, negative 1 over 1 does not equal 1, it equals negative 1, and so that was right here, choice D. Okay, now I'm going to do number 8, and that told you that this is the graph. And it's asking you about vertical, horizontal asymptotes, all different kinds of things, and you have 5 choices. Okay, so first of all, it's talking about an infinite discontinuity. We've never talked about it, so forget that as a possibility. So to look for a vertical asymptote, we will set the denominator equal to 0, factor out a 3, or you could have just added 9 to both sides, and you'll see that when x equals 3, there's definitely a discontinuity. Now you have to find out if that is a essential discontinuity or if it's a removable discontinuity. So we're going to factor the numerator. We get this. And we already know that the denominator factors to this. And I can cancel that. So that means that at x equals 3, it's actually a removable discontinuity because I just removed it. So if you look at the choices, it says there's a vertical asymptote at x equals 3. We know that's not true because we just removed it. B, we have not looked at the horizontal asymptote yet. C says there's a removable discontinuity at x equals 3. Yes, we know that for sure. So we'll just stop right there, and 8 was C. Okay, for number 9, that was very similar to the previous problem. So we need to find out all the asymptotes, and probably the easiest way to do this is to take the denominator and set it equal to 0. I don't know why this is so blurry, I'm sorry. I'm going to try and change that in a second. We'll see if this gets better. Okay, so how did I solve this problem? Because it's annoying. So I put it into my calculator, and I saw when it was on the x-axis, and I got, whoa, that's even worse. Hold on. Okay, sorry, I don't know what's going on here. But I got that x equals negative 1/4 and x equals 2. So we know that these are just continuities, but we don't know if they're removable, like were we able to cancel them? It's because if you look at the numerator does factor. So the numerator factors to this. However, we're not sure about the denominator because that could take a really long time to try to factor. So your best option is to just look at the picture. You can just graph it. And when you graph it, you can definitely see that they're vertical asymptotes at x equals -1/4 and at x equals 2. So if you look at your choices, A is good, B is not good, C is not good because that says y, not x, and vertical asymptote is x equals. D is no good, and E is no good. So the answer was A. And we have one more to go. Okay, and finally number 10, this was just looking at a picture, and the first one is asking you, what is the limit as x approaches 2? So as I approach 2 from the right side, I'm 0. As I approach 2 from the left side, I'm 0, and therefore the limit is 0, which was choice A. For part B, you were asked about the limit as x approaches 1. As I approach 1 from the left side, I'm 0. As I approach 1 from the right side, I'm 1, and therefore the limit does not exist. And finally, f of 1, which means when x is exactly 1, let me just erase this so you can see better. When x is exactly 1, what is y equal to? And you can see that there's an open circle here, so it can't be that, but there's a solid circle there. And that's when y is equal to 0, and that was choice A. And that finishes the test.